Hello, and welcome. Today, we're going to look at a simple graph that tells a fascinating story. It's the story of a journey taken by three lorries, named X, Y, and Z. Zoom in slightly on the starting point of the graph at 0, 0. Our story begins at the same starting line, at the same time. Three lorries, ready for the long haul. This graph tracks their progress, showing us how far they traveled in meters over a period of 1,800 seconds, which is exactly 30 minutes. Highlight the red line for lorry X. First, let's follow lorry X, represented by the red line. From the moment it starts, lorry X is a picture of consistency. It moves at a steady, constant pace, never stopping, never slowing down. As you can see from the steep, straight line, it's the fastest of the three, pulling ahead of the others early on and maintaining its lead throughout the entire journey. The highlight moves to the blue line for lorry Y. Next up is lorry Y, shown by the blue line. Just like lorry X, it maintains a constant speed. It's a reliable and steady driver. However, its line is not as steep, which tells us that it's traveling at a slower, more cautious speed than lorry X, but without any interruptions. The highlight moves to the green line for lorry Z, but the most interesting tale belongs to lorry Z, the green line. Lorry Z starts its journey at a good pace. But look what happens at the 600-second mark, or 10 minutes in. The line goes completely flat. This means that while time was ticking by, lorry Z wasn't moving at all. It was stationary. Perhaps the driver took a well-deserved coffee break or had to make a delivery. After a 600-second or 10-minute stop, at the 1200-second mark, the journey resumes at the exact same speed as before. The full graph is shown again, with calculation formulas appearing on screen. So, what does this story look like in numbers? Let's describe their motion and calculate their actual speeds. We can find the speed by dividing the distance traveled by the time taken. Here is a formal description of the motion and the speed calculations for each lorry. Lorry X, red line, description of motion. Lorry X travels at a constant speed throughout the entire 1800-second journey. This is shown by the straight line with a constant positive gradient, starting from the origin. Speed calculation. To find the speed, we take the total distance and divide it by the total time. Asterisk distance equals 45,000 meters. Asterisk time equals 1,800 seconds. Asterisk speed equals 25 meters per second. Lorry Y, blue line, description of motion. Lorry Y also travels at a constant speed, but it is slower than lorry X. Its graph is also a straight line starting from the origin, but its gradient is less steep than that of lorry X. Speed calculation. Asterisk distance equals 36,000 meters. Asterisk time equals 1,800 seconds. Asterisk speed equals 20 meters per second. Lorry Z, green line, description of motion. Lorry Z has a three-part journey. 1. 0 to 600 seconds. It travels at a constant speed. 2. 600 to 1,200 seconds. It is stationary. The distance from the origin does not change, so its speed is 0 meters per second during this interval. 3. 1,200 to 1,800 seconds. It resumes traveling at the same constant speed as it had in the first part of the journey. Speed calculation. When moving, we can calculate its speed from the first part of the journey. Asterisk distance equals 10,000 meters. Asterisk time equals 600 seconds. Asterisk speed equals 16.7 meters per second. Summary. Lorry X moves at a constant speed of 25 meters per second. Lorry Y moves at a constant speed of 20 meters per second. Lorry Z moves at a constant speed of 16.7 meters per second but is stationary for 600 seconds, from t equals 600s to t equals 1200s.